an organization, we do not expect someone higher up in the hierarchy to intervene as long as the subordinate can handle the work. The same goes for electrical circuit breakers. We do not want the breaker higher up in the hierarchy to operate as long as the subordinate can handle the fault. Hello, this is Varinder, and today I am going to tell you about what breaker coordination is, how it impacts your electrical distribution, and why it is needed. Circuit breaker coordination may also be known in different areas as discrimination or selectivity or selective discrimination. It is a technical topic, but I will explain it in as much of a non-technical manner as possible. So keep watching, because this is an issue which, if not attended to, may potentially elevate a low-level failure to a high-level one, thus resulting in a larger impact. Also, before I start, just a reminder that if you have not subscribed to this channel so far, please do so, because I do have live sessions coming up very soon. Almost everything in a facility works on electricity, and therefore facilities have a large electrical distribution network with multiple switching devices like the circuit breakers, fuses, isolators, etc., which can be used to isolate sections or branches of the network, either manually, let's say for maintenance purposes, or automatically for protection when the system is live. The objective of the network design is to ensure that any faults, when they occur, are contained to the smallest of the areas and limit the service interruption to the minimum amount, meaning that the other areas in the network continue working in a normal manner and the loads are not interrupted. Let us understand this through a diagram. Okay, so this is what you are seeing on the screen is a representational diagram of a typical layout of breakers in the electrical distribution network of the facility. You have a supply side where a high rated breaker is put, and there is a load side where progressively the size of the breaker keeps coming down. Right? If you are looking at a particular breaker, let us say this one, all the breakers on the left side, that is these three of them, are called upstream breakers because it is moving against the stream, and all the breakers on the right side or the load side are called the downstream breakers. Okay, this looks like an organization chart, doesn't it? That's what I mentioned earlier. Now, let us see what happens when this particular breaker trips. The reason could be anywhere, but if this breaker trips, it cuts off supply to these two breakers, and which in turn cuts out supply to all these breakers which are connected to them. As a result, so many consumers or loads have lost the supply and they are down. Your downtime calculation starts now. Now, when you have to investigate and find out where the fault is, you really have to go through each and every consumer and load to see where the fault exists, because none of these breakers had tripped. If, as we will see in the coming slide, if the fault had been restricted to these three breakers, you would have had a lesser number of consumer or loads to investigate. Right? Let us look at the impact of a breaker at the next level tripping. So, if this 63 ampere breaker trips, it is connected to only 332 ampere breakers, which in turn are connected only to half the number of consumers or loads. So, you can see that your downtime obviously becomes better, in the sense there are lesser number of loads which are losing time, and it also becomes easier for you to investigate because there are lesser number of loads to be investigated. Right? These situations, the 125 ampere and the 63 ampere breaker tripping, can happen in an uncoordinated circuit. What is desirable and what can be achieved through a coordination of breaker settings is this situation, where every time, most of the times, your breaker closest to the fault trips. It could be this one, it could be any one of them, but the closest breaker trips. So, you can see that the number of consumers or loads affected is very less, and also when it comes to defect fault finding or defect rectification, you have to investigate much lesser number of users. So, how do we achieve this? One, like you have seen, is by the selection of the right combination of breakers. So, we have this breaker, we have this breaker, because the rating itself, a discrimination is achieved, because the current carrying capacity of this breaker is lesser than the other one. The other way to do this is to incorporate the settings which are available on the breaker itself, and there are two types. One is the rating of the short circuit current trip, and the other is the introduction of the time delay for the trip to take place. But it is not as simple as it sounds, because there are multiple types of breakers with different ratings, and each has a unique response to currents vis-a-vis the time that it can withstand the current. This is defined by the current time characteristic curve or simply a trip curve for the breaker as shown in the diagram on the screen. We will not go into details, but just know that coordination is achieved by selecting the value of current at which the breaker should trip or the time for which the breaker should withstand the current or a combination of both. Similarly, we can achieve the discrimination by amount of energy passing through the breaker or even have breakers communicating to each other with the downstream breaker sending a signal or a hold signal to the upstream breaker. Anyway, let us leave that to the specialist. Just know that it cannot be an arbitrary setting, it has to be studied and the breakers have to be adjusted as per the time current characteristic curve. So, I hope you have understood how breaker coordination can help in increasing the overall uptime of the facility and also faster identification and rectification of faults, and also avoid nuisance tripping by limiting the power outage to a branch of the network where the problem occurs without impacting the rest of the network. Normally, the consultant who designs the system will take care of the coordination by providing not only the type and rating of the breaker, but also the settings to be used on a breaker. Yes, breakers do have settings like I explained earlier. Unfortunately, more often than not, neither the contractor nor the team taking over the system ever bothers about handing or taking over the breaker settings. If yours is an existing facility, it is unlikely that the settings are still the same as commissioning time, because there are times when the technicians or the executives adjust the setting to take care of what they call nuisance tripping, thus effectively killing the coordination between breakers, thereby setting up the facility for a larger downtime in case of a smaller fault. Just remember one thing, every time a breaker trips, the root cause of the tripping has to be established before you put the breakers back into service. Nuisance tripping hardly ever exists. Most of the times there is a reason behind a breaker tripping. So if you have found a breaker which is, according to you, tripping without reason, or if your upstream breaker is tripping without the downstream breaker clearing the fault, it is time to call an expert and have the breaker coordination checked out. And if you want to be proactive, you can always have a breaker coordination study carried out for your facilities to eliminate any problem areas. That's it from me now. Until the next time, this is Varinder signing off.